the CIBSE Energy Performance Group has a mission. And the mission is to do those 4 things. I'm not going to read them out. It is a group of people, pretty much anybody can join. But as I say, that's the aspiration and the mission of the Energy Performance Group. There's a website on the CIBSE website, which has a particular page for the Energy Performance Group. You'll find it looking a little bit like this. So if you were to type in CIBSE EPG, it would take you to this page. Lots of really interesting, useful information. There's a LinkedIn page and a Twitter feed as well, where we try and keep members up to date with industry events and consultations that we think are relevant. As I mentioned, anybody can join the Energy Performance Group. In fact, you don't actually have to be a member of CIBSE to join the CIBSE Energy Performance Group. Clearly, we would like you all to be a member of CIBSE as well, but that is actually not a necessity. It is one of the larger organizations within CIBSE, and there's a very active steering committee for the group, which meets on a regular basis to try and figure out what it is we should be doing. One of the really useful things we do is we produce one-page executive summaries on various aspects relating to energy performance, and again, you can find them on the website. They're a very good, very quick read, which I would thoroughly recommend. And then one of the things we do is these power hours. The power hour we used to be obviously face-to-face. They're now generally online. But as Helen mentioned, we bring together a number of experts in the field and ask them to talk very quickly for just 8 or so minutes to give us their thoughts and ideas about the particular topic we are addressing, and then it's given over to a moderated discussion. In the case of this, there's the chat window, and I would thoroughly encourage people to put chats in. I also just wanted to mention there are 2 more events coming up on the 8th of November and the 26th of November. The first one, what does zero mean, is actually going to be a discussion with or a presentation from CIBSE and from LETI, for those of you who know who LETI are, where LETI has developed a series of definitions of net zero carbon, and it's an opportunity for people to discuss or hear what those definitions are, discuss them, and indeed influence them as to what they should be, so that we actually really know what everybody knows and everybody understands what net carbon really means. And then we have one on the 26th of November, which is all to do with how to predict energy in use. So that's what's coming up. And with that, I will hand you back to Helen. Helen, thank you.
Thank you very much, Roger. I am very pleased to introduce you to Geraldine O'Farrell, who will be speaking on historic buildings. Geraldine is a senior building services engineer working for Historic England, and before that, English Heritage for the last 22 years. She specialises in electrical engineering, especially all forms of lighting, fire alarms, lightning protection, and surge protection, and has written Historic England's guidance on all of these topics. She is an advisory member of the Church Buildings Council and sits on the Fabric Advisory Committees for Gloucester and Liverpool Anglican Cathedrals. She is also a member of the CIBSE Membership and Registration Committee and a former member of the CIBSE Council and Board. Geraldine, over to you.
Thank you very much, Helen. Historic England is an executive non-departmental government body sponsored by the DCMS. We protect the historic environment of England through listing historic buildings, scheduling ancient monuments, registering historic parks, and by advising local and central government. Of the total number of approximately 370,000 buildings in England, only 2.5% are at Grade 1 listing, which are of exceptional interest, and only 5.8% at Grade 2 star, which are of particular importance or more than special interest. And the large majority of these groups are churches and cathedrals, which is what I'll be speaking about. Slide 2, please. I'm often asked how we can make a historic listed building more sustainable. Well, by keeping them usefully employed and not allowing them to fall into disrepair and decay, we save their embodied carbon. By doing this, it means that another structure does not have to be built instead, Historic buildings are more flexible than you might expect, but sometimes they have to be treated and worked on in unconventional ways. When it comes to assisting the sustainability process through building services, there are some quick fixes and there are some other issues that, depending upon the type of installation, that can potentially have long-term impacts to the building fabric if not approached carefully. Slide 3, please. The quick fixes can be as simple as changing the lamps in the lighting installation to LEDs. Other considerations, I think we've jumped one, thank you. Other considerations such as the suitability of the lighting design and the age of the installation should also obviously be taken into account. But this is generally one of the quickest, easiest and most economical alterations that can be made to a services installation that has a positive impact and saves energy. Careful thought, however, must be given to where the LEDs are sourced from. As with most things, cheap is not necessarily economical. Some years ago, inexpensive imported LED lamps proved themselves to have characteristics that adversely impacted some people. And sometimes the issue was as simple as having a shorter operating life. There are people sensitive to the imperceptible flicker that some LEDs have. This can cause migraines, nausea, and is not something that can be seen with the naked eye. Instead, the non-visual receptors at the back of the eye detect the problem. It was found to occur more frequently with cheaper LED lamps. This was becoming quite an issue for some churches when they started to install LEDs and were losing congregation numbers because of it. So, purchase LEDs from a reputable supplier became the standard advice in the early days. Next slide, please. The win is even greater if the electrical supply to the building comes from a sustainable source, potentially including that of the building's own photovoltaic panels. Yes, a lot of listed buildings have photovoltaic arrays on their roof. Historic England have never been against these. We normally ask that they be concealed from the main views to the building and not installed on the main elevation. Grade 1 listed Gloucester Cathedral has them as one example, as shown on the right of this slide, as part of their Project Pilgrim works. There were, of course, other considerations to this sort of installation, such as ensuring the often centuries-old roof has the integrity and strength to take the load of these panels, and that there is no imminent need for roof repairs. Also, there must be a safe maintenance access to the panels and an auxiliary equipment found a suitable home within the building or adjacent structures. Next slide. Heating is another major consideration and the one that has the potential to be far more complicated and problematic. Gas and oil-fired boilers supplying a wet radiator system are a favourite form of heating in this country. These types of boiler are, however, falling out of favour as climate change becomes ever more of a factor when deciding which technologies to use and when you replace heating systems as they come to the end of their working life. In a lot of remote places, you will often find listed churches and houses where oil-fired and LPG boilers have been the only option for many years, as the national gas network never extended out to their locations. Replacing one oil-fired boiler with another is now not the first option that should be considered due to both the Church of England's decision to be carbon neutral by 2030 and the UK's by 2050. So what are the alternative options available in such cases? In addition to PVs, which could be used to supply electric heating, the grid is rapidly becoming carbon neutral, and according to the National Grid Electricity Systems Operators Report, it should achieve that in just 4 years' time. So consideration to electric heating is one option, either by electric boilers or other forms of direct electric heating, such as storage heaters, radiant panels, etc., depending on how the building is used. However, there's no point in heating a church 7 days a week when it is only used every second Sunday of the month. Also, systems such as radiant heaters will only warm organic materials, humans included, and not the building. So there may be issues with condensation and damp in the long run. Undoubtedly, you will have heard of the intended use of hydrogen to replace natural gas. There are several companies who are working on hydrogen ready domestic boilers, which will only require small modifications to use hydrogen as their fuel when it comes on stream. There is a lot of work to be done before this can happen, and the first recipients of hydrogen as their main fuel source will be industry, who are larger contributors to carbon emissions rather than domestic users. There are also ongoing discussions as to which is the better form of hydrogen, be it produced by thermal chemical processes, which use methane in natural gas with a byproduct of carbon dioxide, or when it is produced by the electrolytic process using electricity to split water into its component molecules of hydrogen and oxygen. The first is referred to as blue hydrogen and the latter green hydrogen. Many people are now considering that blue hydrogen is not a true green alternative. Next slide, please. There is, of course, heat pumps to consider. Whether air, ground, or water, they are becoming a popular option, sometimes needing a small boiler as a backup, depending upon the application. Churches are, in a lot of cases, amending their traditional layout and removing their pews and installing underfloor heating, for which heat pumps are a suitable heat source. These alterations are often because churches are employed for more additional non-ecclesiastical uses these days, and often need a more flexible internal layout to allow that to happen. These are often musical concerts, plays, creches, indoor farmers markets, and yoga classes, amongst others. Next slide, please. As long as a building remains in use, it can be employed, as we see on the right-hand side here, which is the Shrewsbury Flax Mill, which is being converted into offices. Otherwise, it will go shortly into decay, as shown on the left building, and will rapidly probably have to be pulled down. So it's in all of our interest to keep heritage working for us, and building services helps to make the suitable changes to the building to enable it to go forward into the future for everyone to enjoy. Thank you.
Thank you very much, Geraldine. It's really interesting to learn the church set itself a net zero goal by 2030, and to understand in the context of historic buildings just the challenges that face them. So I'm sure there'll be many questions coming through for you. So now we move on to Tina Fawcett. So Tina, please, can you share your slides? And while Tina's doing that, I will introduce her to you. So Tina Fawcett is based in the Environmental Change Institute of the University of Oxford, and her research concerns energy use by households and organisations. She uses a multidisciplinary approach to understand current use patterns and to identify opportunities and policies for reducing energy use and carbon emissions. She leads the Policy and Governance theme in the Centre for Research on Energy Demand Solutions, CREDS. Her research work within CREDS focuses on policy for further, faster and more flexible delivery of energy demand reduction, particularly in relation to the energy use of buildings. She also works on the Energy Superhub Oxford, a large demonstration project trialling smart local energy systems, Benefits, a project on the multiple benefits of energy efficiency for businesses, and the EPSRC network for the decarbonisation of heating and cooling. Tina, thank you for giving us your talk. Over to you.
Okay, thanks very much, Helen, and thanks very much for inviting me to speak. This is it's a really nice opportunity. What I'm going to do is talk about residential retrofit, so obviously at a very different scale from the buildings that we've just been hearing about. And I'm going to highlight two recent pieces of work that have been done in the CREDS Research Consortium. They're quite different pieces of work, but I hope you'll agree that together they sort of highlight some important things about residential retrofit. Right. So this is the headline figure. We've just published a report where you'll see the link on the slides there in CREDS, led by colleagues at the University of Leeds. And what we're trying to do is look at energy demand reduction as a route to meeting climate goals. So the net zero goal by 2050. So this is looking at only reducing energy demand. It's not looking at the carbon intensity of the energy, and it's not looking at carbon capture technologies. And what we have found is if you using technologies that we already know about, and behavioural changes and institutional changes that we already know about, we can reduce energy demand by half by 2050. And that can be a really important part of our transition towards net zero that's often overlooked. And this is showing more savings from energy demand than are usually recognised even by the Committee on Climate Change. And what I'm going to do is just briefly tell you a few of the headline things from the report. So I've got one of the graphs, the key graphs from the report here, which goes from 2010 up to 2050. And you can see there's 4 different scenarios. The top scenario, ignore, is the scenario where we just look at what current policies are saying they're going to do. Now, bearing in mind, this is before the government's latest slew of documents that came out last week. And if we do that, energy demand in the whole UK economy, we think will reduce by 5% by 2050. But if we do our transform scenario, we can get this 52% reduction that I've talked to you about. And it's called transform because it's not just about energy efficiency, this scenario. It also looks at transformative change in social practices, in infrastructures and institutions. So it might include some of the measures that we hear the government decided not to publish, looking at perhaps reducing meat eating, doing a bit less flying, doing a bit less traveling, as well as all the efficiency things and so on that you would expect. So just to show briefly some of the detail that is under there, if we look at buildings, on the left, we've got the ignore, sort of business as usual scenario, and on the right, we've got the most ambitious, the transform scenario. And the 2 things I would say, and this is sources of energy sources for all uses of energy in residential buildings. And if we look at the ignore scenario, as we've already talked about, energy use is more, well, it doesn't go down very much, goes up a bit again by 2050. If we look at transform, you can see total energy demand in the residential sector falls substantially. And the source of that heat moves totally away from fossil gas and moves largely towards electricity. And if we look again at some of the sort of further detail underneath that, we're looking here at heat delivery technologies in the residential sector. So that's the previous one was all uses of energy in the residential sector. So again, if we look on the left-hand side at the business as usual, what we're seeing is not a great deal of change, still mostly reliant on gas for residential heating. If we look at the transform scenario, you can see by 2050, we no longer got any gas boilers in the UK housing stock. We've got a considerable amount of heat pumps, which we've already been hearing about. We've got some hydrogen boilers, again, already mentioned by Geraldine, and we've got some heat networks, and we have got some, and then the top purple there is the standalone water heating. So as you can see, it's sort of seeing big changes in the technologies as well as changes in the total amount of energy that's needed to provide the services people need. So and there's a great deal of detail in these reports. And I must say I didn't do the modelling myself, so I don't know all the numbers, but there's a great deal of interest in that report, and I would recommend going to the website to have a look at it. Now, my second piece of research I'm going to talk about is on a totally different scale. This is research that myself and some colleagues did with the Federation of Master Builders. And here we were looking only at energy retrofit in UK homes. And we're particularly thinking about the small builders and businesses that do most of the retrofit or could. And we took a market transformation approach to the analysis. And you can see I've listed there where the report can be found. And so by looking at the market as it is, this is the sort of conclusion we came to. Despite the many benefits of retrofit, which I probably don't need to tell this audience, there's no functioning market to deliver it. And our hypothesis is that to change this, that retrofit to reduce energy demand must become embodied into the everyday practices of builders. And that's the building workforce we've already got. And that was the sort of approach that we were taking in the report. I should say that the report was, although it was written, it was led largely by an academic and practitioner team. We had, very importantly, when we were towards the end and we'd got a set of draft recommendations, we had a workshop with a selection of master builders from the Federation of Master Builders and got them to sense check what we were saying and to agree or disagree with us. And this was and then we, towards the end of the report, we started talking about policy, what needs to change to get to this vision where energy retrofit is in a well-functioning market and it's part of everyday practice for the building firms, and that they are able to do that work. And this is a quote from a master builder: "We've been put off by stop-start policy schemes. They're too risky for a smaller firm. However, we do want to get more involved in this market." So there's a positive and a negative there, really. And I think as many people will say, we know there isn't one simple thing you can do for policy on housing retrofit. It's going to take a joined up approach. It's quite complicated, but it doesn't mean we can't do it. And I think, so if we think about elements of a successful retrofit strategy, again, quite a lot of this is, I think, familiar, but it still needs saying because we're still not seeing it. And we certainly weren't seeing it in the strategy that the government has just put out, sadly. So we've got finance, we need minimum standards for buildings to be more regularly revised. We need a license to trade for building firms. And interestingly, the Federation for Master Builders have been pushing that for some time. We need education and training reforms. We need EPCs reformed to improve their accuracy. And we need detailed policy design, not just sling a bit of money around and hope that will work, because we know it doesn't. We've seen that very recently. So what to conclude, I think making change on the scale in the residential sector is of course complex and challenging. We know that, but there's a great deal of research and practice indicating positive ways ahead. We do really need to focus on energy demand reduction. We can't just think about changing heating systems to low carbon sources. We also need to focus on energy demand reduction. We need to think about policy support at all levels of government, national and regional, and Welsh, Scottish, Northern Irish level. But I would say overall, I think we know what this policy change should look like. There's all sorts of voices saying very similar things on this. Progressive parts of the industry are on board. So I think, really, we need to keep pushing for this positive low carbon future we need and frankly that we deserve. Thank you.
Thank you, Tina. We will move on to Matthew. So Matthew, if you can get your slides ready, please, and I'll introduce the audience to you. Matthew Mapp is a whole life carbon specialist who leads Sweco UK's embodied carbon offering. Sweco is a multidisciplinary built environment design consultancy with service offerings across Europe. With a climate science background and 7 years working at Sweco, Matthew is dedicated to changing the way in which we think about materials in buildings and works with forward-thinking clients to push the boundaries of sustainable design, construction and operation to work towards meeting our climate goals. Matthew is involved in industry initiatives and research, having recently been task group chair for the UK GBC's Net Zero Carbon Roadmap Task Force. Over to you, Matthew.
Thank you very much, Helen. And thank you for that introduction. So as Helen said, I'm leading Sweco UK's whole life carbon assessment for building offerings here in the UK. And today I'm going to talk to you about the subject of whole life carbon and particularly the role this plays in assessing options to retrofit. So I've taken a wide range of whole life carbon assessments for buildings, all the way from sort of 10,000 meters squared, all the way up to 200,000 meters squared, with my main focus being commercial and residential assets. So today I'm really going to talk to you and focus more on the commercial side. So what is whole life carbon and life cycle assessment? Life cycle assessment is really the quantified impacts of materials, systems, products, and in our case, buildings over their entire life cycle. From material manufacture to transport, installation, repair, replacement, and operational emissions, all the way to end of life. When we use carbon as the quantification measure or unit, this becomes a whole life carbon assessment. Now, whole life carbon assessment is in essence an assessment of embodied and operational carbon and the synergies and interplay that exist between these elements. So this is really the whole life carbon balance. A decision made to reduce one aspect can significantly impact the other, and which is why really decision making to reduce carbon must consider both aspects. This is especially important for retrofit really, and this is sort of the key theme of my presentation today. So this balance is really reflected in that changing proportional impact between embodied and operational emissions in buildings. In this chart, we see the operational emissions in grey and the embodied emissions in green. A decade or so ago, we were really sort of towards the far left, where operational emissions dominated the whole life carbon impacts of our buildings. However, due to that significant steps taken to reduce operational emissions, particularly in the last decade, we've now arrived at the second from the right, where although whole life carbon emissions have overall decreased, embodied carbon is now actually the dominant force. So in reality, a robust low carbon development cannot therefore claim to be so without addressing embodied carbon emissions as well. So how do we actually go about reducing whole life carbon emissions? Well, there's a hierarchy approach you can see here as set out by the UK GBC, which really shows the key actions needed to reduce embodied carbon emissions. One of those key factors is actually to build less, to make use of existing materials to lower embodied carbon emissions. This consideration is actually also reflected in industry targets. So here you can see the new London Energy Transformation Initiative embodied carbon targets with offices isolated for clarity. Those of you familiar with energy assessment will see this actually looks quite a lot like an EPC or an energy performance certificate. This process grades embodied carbon intensity in kilograms of CO2 per meter squared of floor area of a building from A++ to the best and G the worst. In the context of this talk, though, it's critical to note that there are not separate sets of targets for new build and retrofit. This is intentional, and I'll show you why now. So let's start with a new build. This is a 60,000 square meter commercial office development that I've undertaken a whole life carbon assessment on. Fairly typical materiality, low carbon aims, but a baseline impact of 1,154 kilograms of CO2 per meter squared. Now, this is considered fairly standard and would probably align with a D rating on the previous slide. What we need to understand, though, is the embodied carbon distribution within this building. So let's look at that now. This pie chart shows the embodied carbon impact is distributed between the labelled elements on the right-hand side over an office's life cycle. What I really want to draw your attention to, though, is this right-hand side of the pie chart. Together, the new build structural elements make up over 50% of the embodied carbon. Now, this is concurrent across most of my office projects in my portfolio, and is actually sort of due to the common materials such as concrete and steel, which have the high embodied carbon impacts. Now, I want you to keep that weighting in mind as we move through into the next section. Now, let's look at a retrofit. So this is also in London, almost exactly the same size as the new build, but this time we've retained over 90% of the structure. We needed to upgrade the facade and the services to reduce the operational energy and have added an extension both vertically and laterally, but you can see how this has impacted the baseline performance down here. We're almost 300 kilograms lower than the new build without doing anything other than retaining the majority of the structure. This would now be a C rating under the benchmarking system, so immediately better than the new builds. Looking at the embodied carbon distribution in this retrofit example, it's pretty clear that the structural emissions have diminished significantly, and this has a really marked impact on the baseline result. However, other elements now have a more significant proportional impact, and this is kind of the point of doing an LCA in the first place. Undertaking this assessment allows you really to understand the proportional distribution of carbon and target areas for interrogation and reduction. Now, it's quite clear in that example that retrofit achieves a significant embodied carbon reduction at baseline stage. And that's kind of why industry targets were set out like they were, to encourage that. But this has also been picked up now in London, particularly by local authorities, which have heard this talked about and really want to push the retrofit agenda. My experience has really been a significant uptick in the challenges from local authorities if you're proposing to demolish and rebuild. What you can see on the screen is actually an example of a typical new build client intent and the planner's response to that. Whole life carbon is actually used as a way to evaluate this. So let's look at what you would do to set this out. First, we'll observe what a client would want to see when trying to justify a new build. Importantly here, we're bringing back operational emissions with embodied and operational together as whole life carbon plotted up the y-axis. The x-axis shows typical reference study period of 60 years. So first we plot the existing building with a minor refurbishment, maybe internal layout and finishes retrofit only. Embodied carbon starts very low on the y-axis at day one, but not doing anything to facades and services to improve operational efficiency means that operational emissions continue to increase significantly, making the line very steep. Next, we plot a more significant retrofit. Here we see the structure, well, we'll keep the structure, but we replace the facade and services and upgrade significantly. We then start higher up the y-axis because there's a more significant outlay of embodied carbon to achieve this, but our line is much flatter, representative of stronger operational energy performance. Finally, we'll plot the new build. This starts at the highest on the y-axis because all the materials are new and therefore there's a significant embodied carbon outlay here. However, the full control over your services and facade can significantly impact our operational emissions. So the overall whole life carbon line is flatter. So to justify a new build, your client is looking really for point A, the point at which your new build becomes more carbon efficient over its life cycle than the retrofit. But is that actually the reality of what we see? My recent experience say not usually, and this is what we usually see. If significant steps are undertaken to upgrade facade and services systems, often the lines never actually meet. This, however, is highly contextual, and there are a myriad of constraints and difficulties with retrofit that are actually not captured here. However, that is why you undertake such a study on a building by building basis. This is not a one size fits all approach, but this is a clear demonstration approach of whole life carbon emissions of retrofit versus new build. So finally, I want to talk about CREM quickly and the issues of asset stranding. So many of you will be aware that clients, developers, many of those I work for have sort of strong climate commitments to address climate change. Many of these developers that I actually work for have climate commitments in line with Paris Agreement's 1.5 degree trajectory. And this is something I feel gets bandied about a lot, but it's rarely ever contextualized. So I'm going to try and put this into context of operational energy and retrofits for you. So CREM is the Carbon Real Estate Monitor. One of the key things we use it for is to assess stranded assets. And a stranded asset is a property that will not meet future energy efficiency standards and is at risk of early obsolescence. And that's really key to understanding this. We assess this by using the graph you see here. Starting with the green line is the energy performance over time required to meet the new Paris 1.5 degree target. The black line is an example retrofit that achieves an energy intensity of 200 kilowatt hours per meter square per year. You can see that after just 10 years, the stranding point in red with the circle occurs at that point. At this point, the asset cannot then meet climate trajectory performance. And critically, if this stranding happens within a typical commercial lease cycle of 10 to 15 years, is there actually any point in undertaking the refurb in the first place? So what then happens if we improve that energy efficiency and energy use intensity to 120 kilowatt hours per meter square per year? The stranding point now happens further along the line beyond a typical lease cycle of 10 to 15 years, thus initially making refurbishment look more viable. But what does this actually take to get to 120? Very likely significant intervention in facade and services to achieve this metric, all at a cost of embodied carbon, which this graph does not show. So finally then, we're back to balance. A whole life carbon assessment is a really critical component of our decision-making process on whether retrofit is the best solution from a carbon perspective, because without considering it in the round, you cannot make an informed decision. And that brings me to a close. So thank you very much for your time.
Thank you very much, Matthew. Okay, so now we move to the Q&A part of the session, and there are a lot of questions and comments in the chat pane. But I'm going to start with Geraldine. There are lots of comments, and Geraldine has been posting responses into the chat pane to certain questions. Geraldine, just invite you to comment on the need for historic buildings to focus on fabric first, and how it's not always possible to make them as airtight as more modern buildings, and the fabric needs to breathe.
As I've said in a lot of my responses, there is no one fix that fits all listed buildings, unfortunately. I cannot say do X, Y, and Z and it will work. What might work for one will end up causing considerable harm to another. What our whole reason for existing is to conserve and retain as much of the original building as possible. And if by putting, say, roof insulation in, we'd allow, or we stop the flow of air in and out of the building, we may end up causing some sort of rot in roof timbers. I've seen it in many churches. Also, fabric from any period in the past, but from the distance past, say medieval times, it just behaves very differently. And a lot of churches and old buildings have got quite a good resistance to external temperature fluctuations. I mean, they tend to have a sort of microclimate all of their own because they have such, sometimes 2 or 3 feet thick walls. What's happening outside tends not to impact upon them. Yes, they can be drafty, but you can't put double glazing, as I've said to one other inquirer, on, say, something like medieval stained glass. It will destroy the stained glass because of condensation buildup. So the sort of conventional ideas of how you would make a more modern building more energy efficient just aren't necessarily, but not a complete no, but aren't necessarily applicable to historic buildings. We just have to literally take it on a case-by-case basis and come and speak to us. And we have a whole host of different experts, and plus we are doing our research, but you cannot research the impact that interventions into historic fabric will have over a short period of time. It takes years of research, I'm afraid, to discover what might or might not happen.
Thank you. Tina, a question to you, based on something you said in your presentation, which is there are lots of voices shouting for action in certain areas, and yet the heating and building strategy of the government hasn't apparently listened to all of those voices. So what are the challenges? What can be done to try and push forward optimal activities? Sorry, government policy.
Yes, that's a good question. If only I knew the answer. I mean, perhaps some people on the, in the audience might have better ideas. We were just debating this actually with some colleagues today, because I think most of us would think actually there's a lot of very good evidence around. We've got good case studies, people have done very high quality retrofits. We've got a lot of, research and practice evidence of what needs to be done. We've got some examples of policy. But the government is not committed to acting on the scale I think we all think is needed if we're really going to seriously reduce energy demand and carbon emissions from the housing stock. I think probably one of the problems is that there is no country that we can point to and say they are doing large scale mass low energy retrofit. It's not happening anywhere at the moment, and that's part of the problem. There's lots of good smallish scale schemes, but finding that country who's actually going to go first and make a serious effort, we don't know who that's going to be yet. It would be nice if it could be us, but I'd be very interested to hear what people have got to say about that.
A question firstly to Matthew, but then to all panelists, which is the government strategy of upgrading housing, but let's take that in a wider building sense, upgrading to EPC level C. Arguably, this is not ambitious enough, and a higher grade should be aimed for. Matthew, would you like to comment on the desire to improve the efficiency of buildings before 2050 and what this might mean for stranded assets, and the focus on operational rather than, as you point out, the need to consider embodied as well?
I think so, yeah. I think that we did a piece of work with the UK GBC recently, and we came up with a similar thing, that perhaps upgrading to just that grade of EPC is not good enough. And what we've got to remember is that there's a disparity between EPC and actual energy use of buildings. And that's something that Tina had talked about before, about reducing demand and understanding the actual energy use of our building in the first instance. And judging a building by its EPC is not directly a good way of assessing its actual energy performance. And there's publications from the Better Building Partnership that have really well demonstrated this, about the fact that an EPC does not accurately represent that data. So there's a difficulty there, because obviously we're only looking at regulated emissions, and there are unregulated emissions which can be a significant proportion of that as well. So there's, yes, upgrading further with EPC is a good idea, but you've got to understand the limitations of an EPC and what that actually means, because we're moving away from design for regulation to design for performance, and that's got to be a strong consideration for the future as well.
Tina and Geraldine, would you like to comment on that, if you have any views?
Yeah, I mean, there's the standard for the building, and then there's what the buildings, how well they need to perform, so that, for example, there's an argument that if you want to reduce fuel poverty, what you should do is ensure that buildings are, I think, either EPC A or B. I mean, admitting, the point that clearly is there's problems around that measurement. so that anybody, the energy demand of the building is low enough that anybody can live there and not find themselves in fuel poverty. So there's that argument. Then there's also sort of contrasting arguments, particularly with the government talking about the rollout of heat pumps, that you need to do less on the fabric because you can supply, as we increasingly decarbonize the electricity supply, we can supply sort of zero carbon electricity. But I think we would all think, actually, as somebody had already said in the chat, there's the fabric first approach is there for a very good reason. There's all sorts of reasons why you need to attend to that, not just carbon. And I don't think anybody thinks it's realistic to do no improvements to the building stock and just sort everything out with decarbonised energy sources. So no, to me, EPC sounds like a point on the way. And clearly we're going to be looking, if we think about historic buildings and, within the housing stock, you're going to likely have different levels of ambition, perhaps, for different types of construction and possibly even for different types of ownership. I mean, social housing has always been ahead of the rest of the building stock for various reasons, and perhaps we'll continue to see that.
EPCs for historic buildings, we are of the opinion that really that whole calculation process is not fit for purpose for heritage buildings. And there is another team that I'm not part of that are looking at this and making representation to get that changed in some way. But in some cases with listed buildings of great age, you actually don't know what they're made of, and all you're doing is making very limited educated guesses. So they mean even less really as to how energy efficient the building is.
I'm going to move to a question about the electrification of heat. Now, this is being put forward as a way to reduce our reliance on fossil fuels and reduce carbon emissions, but that will increase the demand for power and change the current annual trend of electricity, which is pretty flat all year round, to one that has a marked peak in winter, mirroring the current gas trend. Do the panelists have what would they like to comment on that in terms of the additional generation we will need to serve the future demand for power from the electrification of heat, and how we might be able to achieve that? Tina, would you like to go first?
Okay, I mean, I would say yes, of course, but generally speaking, I think if you look at all the scenarios that anybody will create about how do we get to net zero, they all rely on electrification, largely on electrification of heating and transport. And of course, with that means you've got to increase the amount of electricity that we're generating. I've already made the argument that, of course, if you reduce energy demand, that's less the case, but it will still mean you need a bigger electricity system than that we've got at the moment, and that you've got to deal with problems, particularly of seasonal variation in electricity demand, as the very good point that we're a heating demand. Heating demand is very seasonal, obviously, and that's a big problem that we don't entirely know how to solve yet. That's partly why people like to talk about hydrogen, because you can be a form of storage, but most commentators at the moment would say hydrogen's unlikely to be used really that much for residential heating. It will be more used in the difficult to decarbonize sectors like perhaps lorries and shipping, and possibly also buildings like the sort that Geraldine's talking about, where low temperature heat pump heating is not going to be the right answer. So people are doing a lot of serious thinking about this. There's a lot of thinking about flexibility. Once cars are also all electric, clearly you've got a huge battery storage effectively in your car fleet. And people are talking about smart grids, smart networks. I mean, I don't think we know all the answers, particularly around the seasonal variation. We certainly know quite a lot of the answers about the day-to-day, minute-to-minute, hour-to-hour variation and how to manage that in a smart way. So yes, we are talking about a bigger electricity system. And at the moment, that will be primarily, it's going to be wind, will be more interconnected to Europe. So there's some sort of security there. Be some more solar PV. As we know, the government's planning to build one big more nuclear. Some doubts about how much will be biomass and the degree to which that really is carbon neutral. So there's quite a lot of debates around, but there's you know, people obviously are taking this very seriously indeed and thinking about all sorts of technologies, markets, different solutions to delivering that electricity system we're going to need.
Thank you, Tina. Matthew, Geraldine, would you like to comment on that question?
The only thing I would say, and I don't wish to sound negative, I applaud the Church of England for going for an earlier carbon neutral date of 2030. And they intend to achieve that by making all church heating systems, where possible, either heat pump or electrical heating. But they did not, in my opinion, think it through clearly enough, because we do have a shortfall on electrical supply, as Tina's pointed out. And if that is going to be the approach for the whole country, or heat pumps or PVs, or then, as some of the chat has been saying, where is a lot of the funding for this going to come? Because it's not affordable for a lot of churches to increase their electrical supply, to power their heat pump, or even to buy the heat pump. And the same will surely apply to domestic users. So it kind of feels a little bit like the cart being put before the horse. We haven't sorted out our electrical system, our electrical distribution, our electrical generation capabilities, but we are heavily relying on electrical heating for the future. So I don't have an answer, I'm afraid, but it is a concern, especially to us with our involvement with the Church of England.
Certainly comments coming through in the chat pane point to the need for heat networks, which is very rare in the UK, and that's certainly an area that could be expanded, and taking advantage of geothermal opportunities such as the what the Coal Authority are trying to do, using abandoned coal mines and extract the heat that naturally arises from that, which is currently being considered as waste, but putting that into a heat network. We have just a few minutes left, so I'm going to actually call upon each of the speakers to just draw upon something that they may want to just speak on for a couple of minutes, either from the chat pane or from the room presentation or generally, and then we'll close the session. So Matthew, would you like to go first, please?
Yeah, sure.
Thank you.
I just wanted to respond to Professor Michael Corcoran's question. And he's quite right that there's a sort of a balance between embodied and operational emissions, and they go up and down as one decreases, the other increases, and vice versa over time. And the key question to that was, given the importance of this in the next 10 to 15 years, should we make gaining planning permission really difficult without justification of need and evidence that all options for reuse, rehabilitation and or retrofit have been explored? And that is key, and that's a really big point to raise, I think, because I'm already seeing that through the planning applications that we're doing, and City of London are a big proprietor of this, that they challenge everything now. Every intent to demolish, you need to come with what I showed you today in terms of the graphs, but also really detailed studies, which can sometimes take months to do, to really clearly demonstrate if you're going to build new build, you need to have gone through all the options. And carbon, the balance between operational and embodied, has become such an important part of that. I think, though, that they've seen this sort of thing before, and they think that it applies to every single building, and that's simply not the case. It's highly contextual in the fact that in order to actually retrofit properly the building, you need the right type of structure. Things like floor to ceiling heights, particularly in commercial buildings, drive your ability to let the building in the first place. So those sorts of things are really key, and it's a combination story that is project by project. There are themes that run between them, but on a project by project basis, we do these assessments. Sometimes it comes out that the new build, especially if you've got a developer, and there are those about these days I have on my books, who are really pushing the boundaries of new builds, really going above and beyond to drive it down. And sometimes that line does come very, very close. But I think as an overall statement, yes, absolutely, we should be making it harder and harder for new builds to get through if we're really going to drive down the overall emissions.
Thank you very much, Matthew. Tina?
I think what the what Geraldine and Matthew's talks has made you think about is about the timescales, the different timescales our sort of building stocks are working on, and this sort of business of demolition or not. I mean, in the housing sector, it's really pretty rare for people to demolish houses for obvious reasons. In fact, you know, maybe we should demolish a few more. I mean, you know, that they sort of last for a very, very long time, or they're expected to, given the demolition rate. Whereas in the commercial sector, as we're seeing, they've got much shorter lifespans. And again, in the historic sector, that, you know, we're talking, and that's really quite interesting in terms of thinking, well, what does that do to your sort of decision making and the sort of choices you're making around it, embodied or not. There's also the different sort of occupation patterns, clearly, that these sort of buildings have, the different sort of technologies that are suitable for retrofitting them while maintaining the building's integrity. And so, yeah, I think it's just interesting to think across these different sorts of sectors, and what, you know, what might seem obvious in one sector isn't really thought about very much in another sector. So I think maybe we can think across a bit more our sort of building silos, if you like. We might learn some more stuff from each other. It's been really interesting. Thank you.
Thank you. And also extend that learning from each other across the world as well. We don't have the answers in the UK. There are lots of other systems being used successfully in other places that we could learn from. And Geraldine.
There have been a couple of mentions in the chat about underfloor heating, and where air source heat pumps and ground source heat pumps are often used to supply low-grade heat for those. We have no problem with any of that, and they're very good ideas and often used in churches. But if you have a floor of historic importance, then that immediately does away with that, or putting any underfloor insulation in. It goes against everything. You know, if you're going to pull up the floor, you are in the process undoubtedly going to destroy some historic significance. There's also the issue of biomass boilers that a lot of people look at. We now question where the greenness of biomass boilers ends and finishes, depending on where the fuel comes from. If it's a sustainable source, obviously that's fine. But in a lot of cases, I think people also forget the need for a constant heat load, and also the maintenance on a daily basis of removing ash and delivery, access and storage. So although a lot of people have some great ideas for heritage buildings, they have to take into account the limitations of the site and the limitations of what the listing allows them to do. It's an ongoing process within Historic England. We are investigating this every day, week in, week out, to try and to provide information on our website to help people. But as I say, investigating listed buildings is a long-term process, and we've got years of studies ahead of us still before we can actually come out with definitive answers. They've been around for thousands of years in some cases, and we'd like them to be around a bit longer so everybody can enjoy them. And we don't want to have to appear negative. We're very much behind sustainability and carbon neutrality, but not at the cost of our nation's heritage. We have to preserve that as well. So it's finding a common way through both concerns.
Thank you very much. That brings us to a close for this event. Thank you very much to our speakers, and also to our audience, who are also very experienced and have put their knowledge into the chat pane. Thank you very much, and goodbye.